All right, welcome everyone. So what we're going to do now is take the next hour and a half and talk about the one design question that we have and the bunch of other questions that we have, the DP problems. So what I'm looking at for right now is to walk through the design questions. So is there anyone here who's taken a look at the design questions and would want to talk through it? Anyone at all? So let me
just one question to clarify.
Go ahead.
So when you say 30-minute increments, the input will have the start time and end time, right? The interval will have the start time and end time of every 30-minute increment.
Yeah, the 30-minute increment is just to simplify the problem space. So what we are looking at is saying that you will know that somebody is free between 1 o'clock and 1:30, 1:30 and 2, 2 and 2:30, 2:30 and 3, as opposed to it being 1:34 to 1:55 or something like that.
Okay, so for every person we'll have a bunch of intervals of start time and end time when he's available.
Correct. And those start time and end time will be in the half an hour increments, which means that it will either be 0, 0 or 30.
Okay, yeah. And do we have any limits on I know it's 7 days, so the maximum number of 30-minute increments could be 7 into 48. So that's the max number of intervals we want to store for one person.
So for any given person, you will have 336 intervals, which is actually 24 hours time 2, which is a half an hour period, times 7 days, right?
And is there a limit on number of persons? We should handle large number of persons or any number of
That's an excellent question. Let's assume that this is large organization, so between 500 to 10,000 persons.
Okay.
1K to 10K.
Okay.
Yeah. Fairly large, but not really. You're not trying to. You're not having millions of users or something. You're just talking about 1 to 10,000 users. All right. Go ahead. Anybody else with any other questions, concerns? Just to restate the question for folks who haven't seen it yet, it is already copy-pasted in the Etherpad. If you're not seeing it, please do log in there. The question is that you're expected to design a meeting scheduling system where you will be given a meeting with of a duration, and even the meetings will be in 30-minute increments. So I will be asking for a meeting that will be set from 7 p.m. to 9 p.m. or something like that, and I'll also give you a group of participants. And goal here is that assuming you know every participant's availability in 30-minute chunks for the next 7 days, so you know exactly what the availability is for people for the 336 interval periods that we have. Your goal is to find out if a meeting is possible where every participant is available. That is the first question. Once we solve that, we can complicate it further, but if you're not able to schedule a meeting or if nobody is available at the same time, then we need to say that, sorry, we cannot schedule the meeting because, well, guess what, nobody's available.
Vivek,
so how would we go about designing it? Go ahead.
Can I chime in?
Yeah, sure, go for it.
Yeah, so the one way I thought about it is it's probably a very naive way, but since you gave a criterion that there are very less number of participants, 1K to 10K, what we could do is we could have a 2D matrix, a 2D Boolean matrix. Okay.
One second, Pramod, just 1 second. Just confirming, folks, is there anyone who actually has concerns with the question? Is there anyone who does not understand what the question is? All right, go ahead, Pramod.
So what I was thinking was, just restate what I was thinking. I was thinking of actually having a 2D Boolean matrix, P cross T. P is the number of participants, and T is the meeting time, right? So it's a P cross T matrix, and Vivek just said that there are 336 intervals, right? So the number of columns in that matrix is basically 336, and we have P participants. Let's say, to start with. What we go about doing is we try to fill. So since I told this is a Boolean matrix,
can I interrupt and ask a question?
Go ahead.
Sure.
Is it like any 30-minute increments, or like we have, like, for example, we do 30 minutes increments by half an hour? Like meeting has to start at 10 o'clock or 10:30 or 11 o'clock. It can start at 10:05 and go to 10:35. Like, what's
fantastic question. So from a simplicity standpoint, the meetings will always be aligned to the hour or half hour boundary. So you will always have the meeting between 10 to 10:30. It's not like 10:01 to 10:31.
Yeah. Okay.
It's always like the full period, and it's always in the 30-minute chunks are always aligned to the hour or half hour boundaries.
Great. So Pramod, this will simplify your metrics, right? So.
No, that is why it's simple. 336 is based on that.
Correct.
336 is. Oh, it is not within a day, or it is?
No.
336 is within the whole week.
Okay.
I think you just joined when we had that conversation just a minute before you joined. Probably is that there are 24 hours in a day, and there are 2 interval periods per hour. So that's 48 in each day, times 7 days, because we have future visibility of 7 days. So there are 336 interval periods in 1 week.
Okay, thank you.
That's where the 336 number came from.
Number.
All right.
Can I continue?
Yeah, go on.
Yeah. So I was just saying that we basically fill the 2D matrix like something like this. So I know it's a very badly written, but it's just that these are the number of meeting times, and let's say there are 4 participants, 4 meeting times. Our goal is to find the earliest time. So I just want to restate the question. Our goal is to find the earliest possible time when every participant is available. So the one way to figure this is to identify which column has all ones. So that can be done using a simple bit manipulation operation. So your goal is to find that one column. In this case, it's the third column, which has all ones. Right? Is there any issue with this approach?
So your 1 is available and 0 is not available, is it?
Correct. Yeah. Correct. So this will be extending to 336. So this is like, yeah.
No. Take a step back and can you talk about the API that will be available to you? Because line number 11 in this text says that assuming you know the participants' availability for 30 minutes, what kind of API would you define that will actually give you the availability for a given participant?
Okay. Okay. So basically, I would get an input of the times which the participant is available. Correct? That's what it's saying. So I'll have a 336 long array, and it will tell me when the participant is available during what time.
Okay.
It will return you zeros and ones, or it will return you only the places where it is 1?
Yeah, anything is fine. I mean, all I want is if it's just saying the only things, yeah. So that's a good point. So basically, is it returning a tuple? So one other way to think of this is this is a time slot, comma availability. That's or it can just tell me the set of time slots which when it's available, right? So So then I
that
can.
Will reduce your API cost, right? Assuming if you call the first person and say out of these 360, how many periods you are available, and it tells you. Now that is your metrics that you will pass into the second person. So with ON, you will be able to figure out what all times suits everyone.
Okay. Okay. Yeah.
Algorithm. Are you able to hear me?
Yes.
Yep. Go ahead, Nate.
Okay. I mean, if you are looking for an algorithm for this, I mean, I'm not looking at it from a discussion, design point of view. I can algorithmically, I can think of a very simple way. I mean, just sort you think of each of the intervals where people, if you look at each person's calendar, for that week you have a start and end time for every time they are. You could either consider as this calendar as showing, if it is showing free time, then it is a free time, or you can, if it is showing block time, it is showing the start and end of the block time, right? So you just sort it across all the people, and then every time you see a start, increment a counter. Every time you see an end, you decrement the counter, and if the counter reaches the number of people who are there, that's the first time they're on. I mean, am I making sense?
So based on to that, if I just extend your idea, why don't I if I have the sorted list of everyone's time available, then why don't I take the max of the mins?
What do you mean, max?
Max. So the max value of, for example, one person has availability at 1, 2, and 3, right? Other person has availability of 2 and 3, right? So out of assuming I need to set up with just these two people, right? So I take 2 and I check if the first person has availability or the rest of the folks have availability at 2 or not, and then I check for the next one. Or it can be a min heap. No min heap.
I mean, yeah. I mean, this is. I mean, I'm just asking. I'm not thinking about it as a design at all. Like if this was an approach for how you could do it, if you look at it like exclusively like an algorithmic question.
So can you just restate your approach? I couldn't follow it up. Sorry.
No, I'm just saying that if you think of it like a person, a number of if each interval that they are free, right? You can take it as a start and end, right?
Okay.
And you just start. You have a bunch of intervals for each person.
Okay.
Right. You just sort.
Okay.
All of these
timestamps. Okay. Okay.
Yes.
I get it.
Okay. Right. All of these timestamps. Right.
Okay.
And now every time you see a start, you initialize a counter, right? A counter is 0 or whatnot, right? And then every time you see a start, it means that that person is available, right?
Okay.
And when you see an end, it means that he's not available anymore.
Excuse me, can I interrupt?
Yeah.
Sure.
So what you're saying is that you're just going to count the number of ones and see whether it's the same number of, same number of the people's count, right? So that's something can be easily done with the approach given by Pramod, I guess, because we are just going to add up the numbers in a column, right? So that's we are concerned about the earliest possible interval for us to schedule a meeting. So we'll be starting from column 0, and we are going to count the all the records. So for simplicity sake, we have it as 0 and 1, which means 0 is unavailable and 1 is available. So if we get the same number as the people's count, we can find that there is a possibility for a meeting. So that's what you're trying to say, is it?
Yeah, I think
I have an idea. My name is Samya, and can I interrupt with an idea that I have?
Sure.
I think first of all we can reduce problem space that whoever has the last first time,
Okay.
that would be the earliest possible time where others might be available. Whoever has the greatest, first time.
Okay.
And then whoever has the least end time, that would be around 2. Like, after that, it's not possible to schedule a meeting.
Okay.
So I think maybe, that can be a first step. We can basically eliminate all the time slots that are before the last first time and earliest last end time.
Okay.
And I think that would be step 1. And after that, I'm not sure. Like, it seems like we can put remote approach, but I'm not sure.
Just one interruption. Yeah. I just want to come back to Vivek's question. The thing is, he wants to know what is the interface which we should have. So, any thoughts on? Can anyone just share his or her thoughts on what is the API call which we would be having? I'm still trying to think of that. If that's what Vivek is also wanting. So
how do I see it is, usually if we see people's calendar, except a few very, very busy people, most of the people have more free time than
hey, speak for yourself. Everybody is busy these days. No, but go ahead. I see what you're saying.
So so based on to that, again I will go back to the same approach earlier. Like, assuming given, so like for a particular person, right? I have 336 slots, and I need to figure out which is the first available time that I have. I think.
So do we have all the information that we need to proceed with the design? There were some great questions in the beginning which talked about the finite time period concept. So that made fantastic sense, and I think you guys did a good job of asking about that. There was question about the number of people in the organization, but did we ask a question about how many people in the meeting? In general, like what is the number of participants? Is it like, do we typically have meetings which have 5 people, 10 people, or do you generally end up scheduling meetings which have hundreds and thousands of people?
Oh, I thought that 1K to 10K persons is the number of participants into the meeting.
Yeah,
that is the size of the organization. Okay, fair enough. I could be easily mistaken. That's a fair point. So the number of, this is 1K to 10K is the number of persons in the organization. And a meeting typically would contain anywhere between like 2 people to like say 100 people max.
Oh, then actually this is a very simple, like then we don't need to think about a big scale.
Right. Now then there's more, right? Then the next question is like, what is the duration of your meeting? Is your meeting typically an hour, 2 hours, 10 hours, or do you want meetings which are 100 hours or something like that? Like what is the meeting period typically, or what do you want to optimize for? Because if you want to quickly find out if you can schedule a meeting or not, you can actually keep track of the longest available interval period for every member. And if your meeting exceeds that, you can just say get lost. You can't schedule a meeting. There are like optimizations you can do depending on what kind of requests that keep coming more often than not. Your goal is to find out, what are the possibilities? You're saying that number one is basically saying you can't say can't schedule meeting is what you can say, right? Okay. That's a possibility. The second one is for you to say that here's the meeting time. These are the two options that these are two responses you have. If the scenario is that the can't schedule meeting time actually happens fairly often, given the circumstance, given the scenario. Like a classic example would be if you're trying to not schedule a meeting, but actually I find a meeting room, right? In that case, not being able to find a meeting room is actually a very common scenario. So in that case, I would actually do it differently.
Can you repeat the last point after you said after longest available interval period, like not able to schedule a meeting, meeting room?
Well, so the whole idea is that if there are two responses that your API is expected to give. One is actually to say that you cannot schedule a meeting because none of the participants are actually having a free slot that will work for you, for all of them.
Okay.
And the second option is to say that here is a meeting time where everybody is available, right?
Yeah.
Those are the two possibilities. Now, if you have a scenario where the response of saying that you cannot schedule a meeting is actually very common, like of the requests that you get, like 10% of the requests are almost always saying that you can't schedule a meeting, and you can optimize for that, then you can do that. Like if your use case was something like finding a meeting room or a conference room that is available, then the answer for that is actually more than 50%, it's actually not available.
As in all the participants are available, but the conference room is not available. Is something like that is what you're saying?
No.
Okay.
So ignore the conference room for now. I mean, I was actually trying to make a point in terms of saying that if your response is that, then you can actually create some extra data sets that will tell you whether you can schedule or not.
Vivek?
Go ahead.
So are you saying that we can design a system based on the responses which we get frequently? I mean, the operations which get frequently, which happen. So if it's with the room example that you gave, if it's almost for 50% of the time we don't get a room, which means that we should concentrate more on that. Is that what you're trying to say? I mean, am I getting
Correct.
you right?
So essentially, absolutely. The idea here is that in any design question, you are trying to one of the optimizations that you can do early on, and it could be a trivial optimization or it could be the real optimization depending on how you look at it. One of the things you can do is to see what would be the expected response patterns for your function or functionality, and start looking at what are the common failure modes and see if you can quickly get to that answer without having to do a whole bunch of computation. I mean, in theory, what
like
you can do is go on, Geek.
So so in this question, like by the question how it was formed, design a meeting scheduling system where you will be given a meeting of set duration, incrementing a group of participants, right? So how I see it is that the meeting room, because it has its own calendar, at least that's how it is implemented in Exchange, it is also one of the participants, right? Now you could have some higher priority participants, like you can have a priority queue of participants, how you are going to check for the meeting availability, like maybe based on the seniority in the organization or the meeting room itself. But like meeting room is one of the participants, right?
Correct. Now the meeting room is sort of a red herring, so leave.
Yeah.
Okay. So go on.
One doubt or one question is you talked about the size of the meeting, right? That is one issue. So you said 2 to 100 people, or the let's say the K people are meeting. So do we get the group also as input? That means we actually get everyone's availability, but we need to check the availability of a smaller group out of this whole organization.
So what would you ask for in that for that group, like the small group that you're asking for? Like what would your functionality look like? I mean, I would assume it will be something to the effect of schedule meeting would be your function, okay, or like basically find meeting time or something like that. Okay, and then you would actually be providing with a list. Right, that's about it.
Yeah.
And what would you be returning?
Yeah, the participants, and you also need the duration, right? How long the meeting you want.
The duration. Yeah, that's one more thing. But just the list is not enough, right?
No, not from time. Sorry, just the duration.
Just the duration. Yeah.
Okay. Okay, and
What
where
would
is
you
the
return?
I will be returning basically a number from 1 to 336. Let's say that way. And
How will you return empty?
empty minus 1. Okay, minus 1. If I can't find something, I'll just say minus 1.
Not a good answer for a design question, but go on. I'll live with that.
Yeah, I mean, you could think of it like either you create an object which stores whether you put a Boolean value and a proper start time, or
minus 1 null if it's an object. Those are fine.
Yeah.
That's not the crux of the conversation, so we're good there.
Yeah.
Okay, go on. Now, where I was going next is what kind of API do you think will be available to you? I'm just reacting to number 10, which says that the participant availability in 30-minute chunks. What would that API look like?
What I am expecting is a list of start and end times that they are available. I mean, if it gives me the times that they are busy, I can do an inversion myself, or I can, ideally, they would just give me all the time that they are available, all the start and end times that they are available.
And what would that data look like? Would it be in interval periods, or would it be in?
Ideally, it's a list of sorted intervals.
If we know the start time is enough, right? Or since it's just in 30-minute increments, if we know the start timestamp, we can always see. I'm just trying to nitpick your.
So take a step back, because it could be that you could say that Pramod is available from 9 p.m. to 4 p.m. That could be the data that comes to you.
Okay.
Or the data that comes to you is actually an array that says Pramod is free at 9, he's free at 9:30, he's free at 10, he's free at 10:30, he's free at 11, he's free at 11:30, and so on. It could be either. And the question for you is to see which version or which flavor would you prefer. That was actually the question that I was saying. And there are different ways to depict the availability data. Which depiction would actually help you?
At least for the solution that I have in mind, it's going to be list of intervals, that they are free. So it's good like 9 to 10 p.m. 10 or 11 to 12:30, and then 1:30 to 4, something like that.
So can I interrupt?
Go on.
Yeah, I was thinking that the object that we receive should be something of an interval. We don't actually care about each and every interval the person's availability, So we are just caring about whether he is available for an interval. Say, just like you told me, say if you have data like a person is available from 9 a.m. to 4 p.m. So we now have the interval, right? And we can just make use of this interval to find whether the meeting is possible or not. So since we know the meeting duration, so which has a start and end time, it's fairly easy to determine whether the meeting is possible. It's really simple in that case, but I'm not sure how I can develop this to make sure that it works when there is a meeting. How can I find whether a meeting is possible or not? Am I making sense?
Like, given if we get an interval or not get an interval, how that would solve the problem? Because in the worst case scenario, you can still get like half an hour intervals for like 335, or like assuming a person has randomly like meeting every half an hour. So for the worst case scenario, you will again have a list of half an hours.
Right? I mean, so a person we are going on the increments of this one, right? 30 minutes, right? If the person has meeting every half an hour, then
every other half an hour, like every other half an hour.
Yeah, if you have every other half an hour, then you have.
Yeah, so the worst case scenario, the input is going to be the same either way you go. So.
Yeah, a bunch of start-ends.
So at this point, should we focus on get availability? What get availability should be? What is the best get availability return type, or should we actually focus on find meeting time? I'm just asking this question out of curiosity. Like, what would be the ideal step to do? Because
well, it depends, right? It depends on how the availability is given to you. will actually change your algorithm.
So one of the questions, can people be double booked in a sense that it's at least in real life it is possible, but in this case maybe it probably doesn't change anything. It's okay, I guess. It doesn't matter.
Okay. So I think there are like two possible solutions, and definitely from exploring the solution standpoint, you all should be looking at both options and saying that if I were to be given, see, the problem has been limited to 30 interval periods, right? That's why the whole concept, that's why it makes it easier for you to even explore the second solution, like the solution where you have I am available for like interval period 1, 2, 9, 12, 14 and so on is even possible because you're doing it in this form. Had it been like, if I were to say that we can schedule it by the minute or by the second, we will be completely out of depth there. We can't do that approach anymore. So it doesn't matter which approach you pick. The solution to figure the answer would actually subtly vary based on the approach. So let us, for arguments purposes, let us actually pick you get back an array of intervals, and not intervals but interval periods where they're available. So it will just be they're available in interval periods 1, 7, like 9, 10, 11, 12, 15 and 25 or something like that, and each of them uniquely mapped to the 30-minute time slots that you have. Let's assume that's what comes back. What would you do with that information? Would you want all the 7 days at the same time, or would you actually prefer getting it in smaller batches?
On 7 days.
Usually it will depend upon whether this API is local or am I making a network call.
You're making a network call.
Yeah, sometimes the batch operation is way better than a noisy or a chatty network.
So the
correct.
question is like
this problem actually also, just let me complete this. This problem also makes it simpler by saying it's available for the next 7 days. What if it is not 7 days, but what if it is for the next 7 years?
Yeah.
Right? You don't want the availability for 7 years unless you otherwise absolutely want it. So you may choose to do it like an increasing scope. Like you may want to see if if the data is available for 1 day, 1 month, like 1 year, and then 7 years or something like that. So you might want to do it in batches. With some overlaps, but otherwise, assuming that's not what we're looking at, let's assume we just get it in batch. So you say get participant availability, you get all their available durations in this. You just get a set of numbers. Is it a set or a list?
Set would be better, I think, because
what's the difference? Like how are you? Like depending upon the language, the set and the list could be the same thing. Like what do you mean by set or a list?
Will they contain duplicate elements?
Okay, not ideally.
No, it should not contain duplicate elements, right?
Yeah, I mean that's why I asked if it can have double book, but at least I think if it's double book, the person can be multiple books. Then the earliest time and the latest time is what is the across all the bookings is what I you can the API can return.
Yeah, but in this case, allowing double booking, then the problem becomes totally different, right?
That's a different problem space. Yeah. And what we're getting back is actually the 30-minute interval periods that are available. So it won't say that you are actually available from 4 p.m. to 7 p.m. It will actually say that you are available at 4, 4:30, 5, 5:30, 6, 6:30, and 7, or 6 and 6:30. You're not available at 7.
That is an optimization. That is an optimization that we can introduce later, where instead of getting like 8 periods which are consecutive, we get just one record, right?
Fair enough. No, I think the question was that are you going to get intervals or are you going to get specific discrete ones? I think I'm just saying for simplicity, let's assume that you get the interval numbers that they are available, and you'll get all of them for the whole week period. So at the worst case scenario, you get 336 numbers, which indicates that they're completely free, and in the best case, the worst case, you'll get interval period which is 0. So now what's the next step?
Vivek?
Yeah, go ahead.
So do we actually need a specific? I mean, do we actually need 336 records or values So we can just go on with intervals, right? So it makes it easy, and even in the worst case, it's good, right? So we don't have to keep track of every 30-odd interval, right? So we can have a say if a person is available from 8 a.m. to 8 p.m. we can just can make it easy to not occupy a lot of space.
Actually, it all depends upon. For example, if you have like 7 days 336, right? You can return the output in terms of bit, right? And you can just do a 336 bit operations to figure out what is the last number that you get by doing bitwise operations for all the participants, right? But if you get a range, then it might be difficult to do that, right? So depending upon the way you want to calculate later, it could be an optimization or not.
Okay.
Okay.
Okay. So moving a little further into this approach, right? So the way I would look at either approaches will actually work. Your algorithm will have to change based on that, and you'll have to you're optimizing for one versus the other. Given the number of data elements you're talking about, I might just go the elaborate route and just get 336 data pieces as opposed to trying to optimize that. It's like given 100 people and 300 data records, I don't think it's a big deal there. So let's move on to the next part of the problem, which is that now that you've gotten the participants availability, so you have an array, I assume a double dimension array in this case, which has all the participants availability in one axis and all the participants in the other axis, and you have like up to 100 participants in one axis and up to 336 elements, or exactly 336 elements on one axis, and it's populated with free or busy. Done. Now, how do you actually take this and translate to the earliest available meeting time?
I mean, one thing that you could do is just sweep through the column, right? And then, I mean, it's an O of participants time. I mean, for each column, you can compute the sum. And the first column, the sum in which it is, is equals the number of participants. That's the time they are all free, right?
Okay, but that interval is only 30-minute interval.
Yeah, that's true. That's true. Yeah, I mean, so you could. So if you're looking for a meeting of 1.5 hours, you look in windows of 3 each. So you scan the first 3. If one of them is not, if one of them is not, if there is a time, if none of them add up to the total number of participants, you can just completely skip all of the 3. On the other hand, if the
I think we just lost your name. Yeah. So who else is? Can someone else just take from that algorithm or logic and move it forward?
Yeah. So the time is given to us, right? You want the earliest possible meeting time for a given time period, say 1 hour. Or,
so Vivek, I have a point.
Go on.
Yeah. So we are given a start and end time for the meeting to happen, right? So we have a duration for which we want to make sure whether a meeting is possible or not. So we have a start and end time. Instead of just looping over the columns right from the first, we can just start from the meeting start time, right? So
meeting is not, you're not given a meeting start time. Your goal is to find a meeting start time. All I'm saying is that I want to meet with Arun, Pramod, and Nate and Vivek, that's me, and the 4 of us need to meet sometime for 2 hours. The goal is to find a time where all the 4 of us are available. So we don't know when the meeting is going to start. It could start at 1 p.m. It could start at 2 a.m. We don't know that.
So can I continue with that algorithm? Are you able to hear me now?
Yeah, we can hear you.
Okay, great. Yeah. So yeah, what I was saying was if you have say a 3 hours, 3 hour requirement, not 3 hour, like 1.5 hour requirement, then you look at windows of 3 at a time, and then you depending on which of them add, if the third one, if the second and third one adds up to the total number of participants, then you just have to check one more, the one next to it. On the other hand, if none of them add up to it, you can just skip the whole one and then keep moving, sort of a sliding window.
So let me ask you this question. Do you actually need to build a two-dimensional array for all the participants?
Yeah, it's not needed. Vivek, so what you do is you just add all the availabilities. So you take the column sum, okay, and for each participant you basically have a list of availabilities, and you find the largest window of this array, which has at least equal to the meeting time required.
So one step back. When you do a get availability of a given participant, right?
Yeah.
You get back an array of intervals that they are available in. Correct?
Correct.
Then you go to you have like a overall availability array which starts with all 0. Okay. And then for the first participant, you just go and increment only those places where that participant is available.
Correct.
Okay, so you don't have to store the availability of the participants anywhere. You get the first participant, increment everything where he or she is available. Go to second participant, go increment. Third participant, go increment, and you can just toss their availability out after that. Right. Then what happens is in that availability, meeting availability, like whatever window, right? You have an array which tells you the number of people who are actually available at interval 1, number of people available at interval 2, and so on. Now, going back to Nate's logic, what you do is you check if the first interval that you have actually equals the number of participants.
Yes.
If the answer is no, then you're done. You screw it. Go to the next one. If the answer is like yes, it is, and then you check how many duration periods you want. If you want 3 duration periods, it's a 1.5 hour meeting, so you need to be 3, right? You check the next one. If that is not equal to the number of participants, then you can start from the 4th point. But if that is equal, then you inspect the 4th point. So your goal is to keep it linearly scanning till you find 3 or 4 or 5 or whatever the number of intervals that you want is available. And with one pass of the 336, you would actually have identified this information, right?
Yes. We completely eliminate the two-dimensional array in this case. That's what I wanted to say. Yeah.
Correct. You don't need the two-dimensional array at all.
That's what I'm
saying. Vivek, so can you just repeat the logic that you had, because I felt lost, I'm sorry.
Sure. Oh, no worries. So the basically what I'm saying is that you will call the get availability for a participant as a call, and when you when you get the availability, what you get back is an array of the interval periods that they're available in, right? You know that they're available at 3 o'clock, 3:30, 4, 4:30, and so on. You have that. So once you get that data, you don't have to store it anywhere. You don't have to persist it. What you will do is you have one a participant availability count as a single matrix, single array, one-dimension array, which has got 336 interval periods, and you take the first participant, where all the first participant is available, you just make that location 1. Then you go to the second participant, ask second participant is available, where all the second participant is available, you go and increment that value in the overall availability. So at the end of all participants, when you complete that, go on.
So we are going to store everything in a one-dimensional 1D array, right? So
the 1D array will store, yes, the 1D array will store the number of participants who are available for that interval period.
So I still don't get it. So we are going to call the get availability time for every person and increment the counter. Is that what you're saying?
Correct.
I've given an example there. If you can see this.
I'm just looking.
Yeah. So the availability array is basically telling you for the first time interval how many participants are available. So only one person is available because only P1 has interval 1 available. But second interval, both P1 and P2 are available. But for the third and fourth intervals, P1, P2, P3 are all available, right? So we have 3 pair. So that means all participants are available at these time intervals. So our goal is to find the earliest time when all participants are available.
Yeah. So this is the approach that I was saying, and there is even a more optimization here. As soon as you go to 2, you can drop anything which is less than 2, right? When you go to 3, you can drop everything which is less than 3. So it's going to further optimize where if you don't have that number in your hash set, means you don't need to worry about it.
Here, Jyoti, I have a thought. So to find the earliest possible time, so I'll start a loop, like, okay, what are the possible time, like start maybe the earliest time, like, okay, start from 9, the loop starts from 9, and then I'll check the number of user, like, okay, I'll check the user 1, if he is available with that, then I'll return if it is 1. Then I'll check the user 2, if it's available, then I'll return, I'll just keep it in a loop, number of users. So if I'll multiply the result of the user and then return, if I say if it returns 0, it means the user is not available. Some of the user is not available. I don't want, right? I don't want how many users are available. I'll just return 0. If all the users are returned, then there is some value which is more than 0, and then I'll say that is the earliest possible time.
So,
how this works? I feel this one is this one will return the earliest possible time.
Did you guys follow the approach? So Jyoti, let's take a step back and see if we all of us understand your approach, right? So.
Okay, I'll just give an example. So I'll start.
Yeah, give an example.
Okay, so I'll start for a time, like a time slot 9 to 11. So I'll ask, I have some 4-5 employees. So I'll just loop in. I'll get from the employee 1 whether you are available by 9 to 11. If he returns yes, then I'll make it as integer 1. Then if the second again user 2 and user 3 and 4. So if some of the user.
Hang on. The input given to you is that I want to schedule a 2-hour meeting between 5 people. That's all. You don't. The expectation is not. It may not be 9 to 11. You don't know whether it's 9 to 11 or 9:30 to 11:30 or so on. So how would you do that?
Earliest time, right? So we want to find the earliest time. So that is my loop going to start. So I'll have the complete dates, maybe just start of the day is 9 o'clock. So first I loop between 9 to 11, and then after that again I loop 9:30 to 11:30. So my loop starts like that. Okay.
Got it. This is anyway. But what was this whole concept of multiplication that you talked about?
Multiplication is that, see, if any of this users as if user customer 3 is not available, employee 3 is not available by then, he will return 0. So if I just multiply all this user, then I'll just get 0, right? So
but the moment you recognize one user as not available, you don't have to check others, right?
Yeah.
If the first user is not available, then why bother checking the second user?
Okay, you can stop then. Yeah.
What you're actually recommending is like a brute force algorithm, which is just try to see if you can schedule a meeting at 9. If not, try to see scheduling a meeting at 9:30. If not, start a meeting at 10. If not, and so on. The problem with this approach is that you will actually be checking if person 5 is available at 10:30 to 11 slot at least 5-6 times, depending on the number of meeting intervals. So you'd be re-asking the same question over and over again. So the approach that Ignite and Pramod are talking about is where you would be calculating the total availability of all participants in a given time. And I believe the optimization that you are suggesting, Geek, is that you don't need to actually store the actual number of availability after a point of time. You don't really care whether one person is available, 2 are available, or n. It's only a Boolean flag which is saying everybody is available or one or more people are not available. So it's just a true or false flag after a point of time. It doesn't have to be an integer. Once you have gone through the whole list, it's just that, right?
Yep. So in the end, whatever you get is your output. You don't need to trace through the entire list again to find the maximum number. In the end, whatever output whatever list is left is your output.
Got it. Makes sense. So that's good. And then you go through this. The only thing, Nate, in your algorithm, in your logic, when you're mentioning, you are actually repeatedly saying something to the effect of, I will check the first three, I will check and so on, right? The one thing to figure out is that the moment since we're looking at the earliest possible time, the moment you figure out that there is a break in the fourth interval period is not available, then you can start inspecting from the fifth. The new attempt can be started from the fifth period. You don't have to check 2, 3, 4 anymore, right? Because if you want to schedule a 2-hour meeting, you checked 1 available, checked 2 available, checked 3 available, checked 4 not available, then you just go to fifth period directly. You don't have to start with 2 again.
Exactly.
Vivek?
Yes, Arun.
So Nate's approach is like, say we are concerned about a 2-hour meeting. We are going to choose a quadruplets, so all the possible quadruplets. So in the worst case, we'll be checking all the possible things. So is that what?
No, you won't. You won't.
What I was saying is that.
Nate was not very clear when he mentioned that, but he was also saying the same thing. I was just trying to clarify what he was saying, which is that if you want to schedule a 4 interval period system, you check the first one. Let us say it is available. Then you check the second one. Let us say it is available. You go to the third one, it's also available. Now you check the fourth one. If it is not available, then you can actually start your search again from the fifth one. You don't have to go back and see if 2, 3, 4, 5 is available. You don't have to check all 4 combinations. You just have to start from 5. See if 5 is available, 6 is available, so and so. The moment, because we're looking at increasing contiguous, right? So you don't have to deal with that anymore. So that works. Now, given that you've taken so much time on this one, I just want to ask a thought in terms of saying that what if some participants are optional, and our goal is actually to find a time slot where all mandatory participants are available and the most number of optional participants are available. How would you do that?
So yeah, I mean, you would change the algorithm in here to actually hold 2 values, to hold a count of the mandatory participants and hold a count for optional participants. And
okay,
then
that is a wrong answer. Why?
Can you just repeat the condition which you just said, Vivek?
Yeah, the condition is, let me repeat the condition, see if you're able to catch that, right? So what if the meeting actually contains mandatory participants and optional participants, right? It's not just mandatory, it's basically saying that all engineers are mandatory and all managers are optional, or something like that. And your goal is to say that find a meeting time where all engineers are available, or whoever that we want to, like, if there are engineers and they should be available, and the most number of optional participants are available. There is a question that you need to ask.
All of them should be available.
So we can do it in 2 ways. I mean, do it separately for mandatory participants and for the optional ones, right? So is that something that you are saying?
Yeah. That is not correct, right? Because what do you mean by available? What do you mean by available? A participant is only considered available if he or she is available for the entire duration of the meeting. Otherwise, they're not available. So, in the case of, in the first scenario, even if one person is not available, since you're actually kicking them out, it works. In the optional scenario, that is not going to work, because let's assume that there are 2 managers and both of them are optional, right? And in one interval period, for the first 1 hour, I'm available. The second 1 hour, Geek is available. It will say one person available throughout. That's how it works, right?
No. So in this scenario, like, how I'm thinking is that first you do the same algorithm for all the mandatory participants, and then you get an output, and then you check what is the maximum number of optional participants available in which slot. Like.
No. The first one is you have to modify the algorithm to return all possible meeting times where all mandatory participants are available. That is number 1.
Yeah.
Okay.
Yeah.
Then what?
And the second time is you take now this input and then see where is the maximum number of optional participants available. Like which one of these 4 time slots that you got for the mandatory participant, where is the maximum number of optional participants available?
So I mean, let me clarify. I think So what is the, suppose you gave an example, right, Vivek, where you said that, in one case you are available, in the other case, say, Geek is available. In each of the slot, one of you are available. So as far as I am concerned,
let me take a step back and I'll explain this in a different way, right? So the way I was actually looking at this was that it needs more number of people, but all I'm saying is that the algorithm I understood, like not the one that Geek mentioned, but the algorithm that I thought you guys are actually trying to pitch for is to say that instead of actually summing up the mandatory participants list like we did for the first problem, we want to keep two arrays. One array which tracks mandatory participants and one array which tracks optional participants. Is that what I'm hearing?
At least that was my first proposal. In each slot I was saying that you hold a count for the mandatory, count for
the mandatory. That is correct. The mandatory is simple, right? I understand that you will actually get the right answer for mandatory. The problem with optional is that if you want to schedule a 2-hour meeting, right, and you look at the optional slot and you see that 50 people are available in the optional for hour 1 and hour 2, like interval 1, interval 2, interval 3, interval 4, every number is 50, 50, 50, 50. That doesn't mean that that is the most, because the 50 people who are available on interval 1 are not necessarily the same 50 people that are available in interval 2 for optional people.
So we need to track of the people, the count of people, right? So we need some way
you have to track it has to be by person. It cannot be by that, because if I am not available even for one interval period in that duration, then I am not available for the whole interval period.
Yeah.
I can't attend the meeting anymore. So the approach it's deceptively simple. When you look at the first problem and you look at the second problem, it looks like a very obvious leap, and you have solved a problem in one way. When the only tool you have is a hammer, every problem will look like a nail. And that is not the case here. Be careful there, right? So the approach that you should be taking is what Geek was mentioning, which is basically saying that you would be doing the same thing as the first problem for mandatory, with the exception that instead of like finding the first available interval, you will actually be generating a list of all possible intervals. And as you do that, you may have overlapping intervals as well. Like you may have an interval, like if 1, 2, 3, 4, and 5 are available, you will be returning saying the meeting can be between 1 and 4, or can be between 2 and 5, or it can be between 3 and 6, and you'll have overlapping intervals too. That's what the data will come out. Once the data comes out, you have to go back and check the availability of all the participants for the entire interval period. So you have to see if Geek is available for which of these meetings can Geek make completely. Then you have to keep track of that. So this time the array value is not on a per interval period, but it's actually on the meeting schedule entirely. And then you have to go and sort it by most. The question was, is there a defined threshold for most? There is no threshold for most. If there is no meeting period where none of the optional participants can make it, then it's 0. You still have to schedule the meeting because all the mandatory ones are there. Does that make sense? I mean, it's not a very hard question, but it's very easy to jump to conclusions. So you might want to think through what you're saying. The immediate answer, and this problem has been designed to actually do that, because it looks like it's a logical build-up.
Yeah, it's interesting. What I can also think another way of something similar is actually, instead of storing, at each slot which are valid for mandatory folks, right? You also store the optional person and how long is the optional person available from that point onwards, right? So then you can scan each of them for the mandatory, and the start time, which has you find them for mandatory exactly as you would do for in the previous case, but check for the start time slot which of the ones have the highest number of optional people that are available from that start time onwards.
That will make it more complicated. I don't think you'll have a good data structure to store that information that can help you retrieve it. I mean, my initial assessment, I haven't solved this problem in the same form, is the approach that Geek talked about seemed to be the most logical nodes.
Got it. Makes sense.
Okay. All right. So, and there is a third variation for this question. Is that what we actually, instead of one, like the one classification of mandatory and optional, what if we actually had a system where you had like groups of participants? Like, you have to have one member from like the engineers, one member from program managers, one member from quality assurance as we present. So it's actually a group of people or classifications of people, and as long as one of that group is available, one of the group is mandatory. It's not like a specific mandatory person, but it's like a group of mandatory people. How would you solve that?
You could, my first approach is you can consider each group as a union of all its members. So, union of all the availability of its members. So then you
cannot do that. You cannot do that. If you do that, then what will happen is that if there are like 20 quality assurance engineers and everyone is available for like 30 minute period, you will assume that one person is available throughout. That is not what the ask is. Does that make sense?
Yes. Yeah, that's right.
Careful with your assumption.
So Vivek, I didn't quite get what he was saying. So can you just explain what he said and what's wrong about it?
No, okay. So the ask here first is that you want to make sure that at least one member from each group is able to participate. So you will have groups of, in this case, there is a group of managers, project managers, engineers, and quality assurance, right? So at least one quality assurance engineer has to participate, at least one developer has to participate, at least one manager has to participate, and at least one product manager has to participate. That is the ask. Now, if Nate was saying that we would be able to combine all the users and deal with that, the problem with the combining approach is that let's assume that the quality assurance engineers are like, only one quality assurance engineer is available for first 30 minutes. The second person is available for second 30 minutes, third person is available for third 30 minutes, and fourth person for fourth 30 minutes, right? If that happens, and you do a union of everything, then you will actually be
available yet, right?
You will think that somebody is available, which is not true.
Yeah.
I mean, the intent here or the ask here is that when somebody is available, that will be available for the entire meeting. Otherwise, they are not available. Okay.
So we can do something like this, right? So we have a group of members. So they can start with the member, and if he's available for a chunk, say a 30-minute interval, then we can actually move on to the next, right? So when he is not available, just like in the first approach, we can stop counting him in, right? So we can move on to the next member in the group. Does it make sense?
I don't actually follow.
Oh. So I'm not able to explain.
What you would, what I think, I don't follow this at this point of time. It's like how would you do that? I mean, the advantage of the first approach was that you knew everybody was mandatory, easy. The advantage in the second question was you at least knew who were mandatory and who was not optional and who was optional. In the third approach, you have no idea who is mandatory and who is optional. I mean, you know that the group is like one from the group is mandatory, but you don't know which one. So how would you actually? You can't run your second algorithm, right, without knowing who that person is.
So, hello. Can you hear me?
Yeah, I'm here.
I know this is like a wild approach, but I don't know if it's correct. Can have a min heap of each group's availability, and at the same time we check the minimum element of the manager, minimum element of the PM, minimum element of the QA, and see if they are all same.
What does the heap represent in this case?
The heap represents the intervals when at least one person is available
from the group.
Yes.
But that doesn't change anything, right? I mean, that doesn't. I mean, I don't think it even. Think through it how it makes sense. So why don't we do this? Take this problem requires a lot more thinking. So let's park this problem. I would like to at least take 25 minutes to go through the coding questions. So would not want to shortchange on that. So
at least some clue on this, like what should we be thinking, in which direction?
I'm a little uncomfortable with the clue here because I think it will be giving away the answer otherwise. So,
Okay.
think
Okay.
about it. I think it's... yes, go ahead.
So we need to make sure that there is someone who is available throughout the meeting interval, right? So we need to keep track of the particular person who is available throughout the interval, the window. Is that what we have to track, right?
Correct. A person can attend a meeting or can completely skip the meeting. You cannot have a person attend half the meeting and walk away to be replaced by somebody else for the remaining half.
Yeah, I mean.
Okay, go on.
Sorry, go ahead.
There was a question here saying, can we use a group ID for each user? Yes. I mean, you will have some sort of a classifier, right? I mean, we know the way the input is going to be given to you is that you will be given you're not given participant list, but you'll actually be given groups, and each group actually has a group ID and it has a list of members in that group. And it's kind of what we need. I mean, this is how it works for board meetings and things like that, where you want at least like this and at least that and things like that. So the goal here is you will have a group ID and you will have the participants. So do you have any? Let's stop the solutioning, and I want to see if there's any questions that you have that's going to help you with understanding the question. Is there anyone who does not understand the question? Right. So what I will do is, I think I really wanted to spend about a good solid 1 hour or 45 minutes to 50 minutes on this question, and we are a little over from that standards, and still we are not done with it. So I think design questions are always a big rat hole. It takes a lot of time to get going. I think we may want to dedicate an entire meeting for 1 or maybe 2 design questions or something in the future.
I have just one question though regarding the subgroup thing. If the group has members, say M1, M2, and M3, and M1 is available from 9 to 9:30, and M2 is available from 9:30 to 11:30. Then can the group participate or okay?
I didn't quite follow your specific question, but I think the idea is that if one manager is available between 9 and 10, and another manager is available between 10 and 11, you cannot schedule a 2-hour meeting between 9 and 11 and say we have coverage. Right? Because manager 1 cannot participate in the meeting because he is not available in the second hour, and manager 2 cannot participate in the meeting because she is not available in the first hour. So the person has to completely participate in the meeting. You cannot just have different people join the group and expect participation. Does that make sense?
Okay. Yeah. Got it.
All right.
I have a question, Vivek, a meta question. This kind of design question is asked for what level of engineers?
This would be typically an SDE2 question or a SDE3 question, or it will be a TPM or a SDM question. I don't expect SDE1s to actually solve this question.
Okay.
But we do have scenarios where we get SDE1s ask similar questions, but the intent would be to do the scheduling algorithm, the first part of it.
Okay. Thank you. Can instead of taking a coding question, can we take another design question if you have it? Or maybe more complex one? Or?
I'm not prepared with another question at this point of time, and it will be a little unfair to start a new one without doing that. But we can definitely tackle another one for next week. So I would. Yeah. I may want to do a design question next week. Go on, Nate.
Other suggestion that I have is I might not suggestion, more like another option is we continue doing this, and then we will do the problems we are going to be doing this weekend. We are going to have the session where we'll be doing these questions, right? So maybe we can continue going down this, solutioning the subgroups piece.
not everybody is actually in the in-person meeting. A lot of folks are actually from out of state as well and out of country in certain scenarios. So this group is actually a more diverse and varied group, and not just the same group that meets on Saturday in the east side. So, all right, so I think we have 20 minutes. I do want to pivot to the coding question, at least get one coding question out of the door. And what I can do is I can take the other coding questions up forward and figure it out. So this is like the first question that I have is the longest increasing subsequence. It's one of the classic dynamic programming questions. Is there anyone who has not, who does not know the solution like the back of your head? Is there anyone who actually wants to, vaguely knows, has thought about it before? I'm just curious to get input from someone who's not done a similar question before.
I've done a similar question, but I can't recall it. It's not at the top of my head.
Awesome. Is there anybody else? Just to make sure we get a little bit more participation. I thought I heard a couple of other folks as well, right? Was it Ramya, Jyoti, any one of you?
Hello.
I'm sorry, I didn't get the question. So are you asking if I'm familiar with this?
Yeah, the coding question that I have posted on the blog, and I've pasted it between line numbers 21 through 23, is essentially the goal is, given an array of numbers, I want you to find the longest subsequence of numbers so that all the numbers are actually in increasing order. So if your input is 1, 8, 4, 5, 10, 19, and 11, then you can actually extract 5 elements from it, right? 1, 4, 5, 10, and 19, such that that's one of the answers. Actually, 1, 4, 5, 10, and 11 is also another answer. That's also of size 5. Right? So how would you actually go about solving this? This is a dynamic programming question. Not that an interviewer will tell you up front, but given these kinds of questions are typically easy to detect if you're familiar with them. Any thoughts?
So the sequence need not be consecutive.
It will not be consecutive, or it may not be consecutive. Yeah, that is correct. Your goal is to extract elements, so it may not be consecutive. Go ahead. Any thoughts?
Like, can we do it this way, where say we say like we have a collection, but there are only one element into this, right? How many elements which are before this element, which are smaller, and which are the longest like sequence up to this number, and then we keep on adding one more number to the list, and then see whether like the same thing that we discussed in the last meeting, like including this number or not including this number.
And all the numbers are positive. They can be, there won't be any zeros in this spectrum one.
There will be negative numbers too.
There can be negative numbers too. Okay.
Yeah, the intent is actually to find the numbers in increasing sequence. So the leftmost number has to be the smallest, the rightmost number has to be the largest, and you have to have all the numbers in between in increasing order.
So, Mimi here, I have something in my mind. So if we take a method which takes in this array and one empty array and one simple integer parameter which would hold the index of the array. So what we can do is we can make a recursive call we can start by inputting the first element from our input array into the empty array and simultaneously increasing the index. The index will take it as a static variable to be 0. That's the current value. I mean, that's the starting value. After we add the first element, we'll increment the index by 1, and then we'll make the recursive call, and we'll have a if condition where we can see if the next element which is coming from the first input array, that's 1, 8, 4, 5, 10, 19, 11, if it is greater than the first element, we'll input it again. And if the next element which is incoming, that's 4, if it is less, then what we'll do is we'll decrement the index by 1. So suppose the index was 0, so we input in the empty array, we put 1. Then again we will recurse. In the second call, we'll add 8 because 8 is greater than 1. So the index becomes 2. 0, 1, yeah. No, so first element was added at 0.
The approach that you're actually talking about is in its like simplest form would be you're almost like generating all combinations of including and excluding, isn't it? Is it not?
Yeah. So by that approach, I think I'll get the longest common, like the longest subsequence if I proceed till the end. Not making
you will.
All
the answer is, I think you will end up getting to the answer. You may want to try coding it up, but if I'm hearing you correctly, what you're doing is you're recursively calling the function with or without the current number. So essentially, at every point of time, you are actually bifurcating into two options, right? With 1, you're adding 8 or not adding 8. Then you choose to add 4 or not add 4, but since 4 is not greater than 8, you will not go down that path at all.
Yeah.
Right? So if you had a scenario where if I give you an array of increasing numbers by default, you will enumerate every combination.
Yes.
So this is a 2 power n approach, right? You are actually going down the path of doing that. So that's interesting. How can you do it better than 2 power n? Pramod, what about you? You had an approach.
I was just trying to come up with the recursive formulation. So what I was thinking was like you can define a subsequence of an array using a start index and an end index, correct? So and you want to increasingly. So how you start the problem is the base case is that the corner case is that the largest increasing subsequence is just the element itself, right? Each element can itself be the largest increasing subsequence. That's the base case. And now we want to start evaluating for every element next to it and the element next to it and so on and so forth. So that's how I was thinking, and I was trying to come up with the recursive formulation for this.
So let me take a jump in and see if I can help you with one of the formulations, right? So let's say that you are actually trying to create you create an array, okay, which actually contains let's call it like L,
LIS,
like largest LIS, largest increasing subsequence, longest increasing subsequence.
Sorry, but where are you typing? Are you typing in the same
26 line 26?
In the same Etherpad, line 26.
Okay.
Sorry. So in line, we've had enough discussions, right? So sorry about that. So
sorry to interrupt. What is this longest increasing subsequence means? I'm not getting that part.
Longest increasing subsequence implies that you need to, if I pick elements from the array and keep them in the same order, like I pick the first element, fifth element, ninth element in the order in which I picked, right? Those numbers will actually have to be increasing from the first element to the greatest element. So in the example that I have, if you look at the Etherpad, you actually see 1, 4, 5, 10, 9 would be 10, 19 would be an increasing set, because if I do 1, 8, right, then I can't pick 4 and 5 after that. Does that make sense?
Okay. Yeah, I got it.
Okay. So if I were to say that what I want to do is you have like 1, you have 8, you have 4, you have 5, 10, 19, 11, right? So what I want to do is I want you to fill these values, right? I'm going to call the values like A, B, C, D, and E, and so on. I want you to fill A in such a way that, so what do you think? Is that represents the longest subsequence in this array ending at this number?
Correct.
The sequence ends here. What is the value of A?
1.
Because there's nothing beyond that, right? Okay. Yes. What is LIS of 1?
LIS of 1 should be 118 is a increasing subsequence, and that is the largest which we've seen so far. It's bigger than 1, just 1. So it's 2.
Okay. Okay. So let's say that you had other numbers here. Okay.
Okay.
X, Y, Z, or something like that.
Okay.
And that had some more values like E, F, G, and so on. What is the longest values of subsequence right now?
It should be index of 8. Okay.
Corresponding date, what is it? It's B. B is what?
G plus 2. No, wait. There's actually a condition. So 8 should be bigger than Z. That's the condition which you have to check first, right? If 8 is bigger than A of I, yeah.
A of J, all the numbers below this.
Of all the numbers below it, yes, yes. It's then the maximum of the that index E, F, or G, whatever it is, plus 1.
Correct. So it's actually max of A of J, where the 8, which is basically A of I, is greater than A of J, and then a plus 1.
Of A of max of A of J, such that A of I is greater than A of J plus 1. Yeah, you're right. Yeah, correct.
So and it's not max of A of J; it's max of LIS of J.
Yes, LIS of J.
Right?
Yeah, you're right. You're right.
Will that work all the time?
A of J. It won't. So.
No, let's evaluate it and see, right? What about 1? 1 is 1. What about 8? B. What is the value for B?
2.
It's 2.
Yeah.
What about 4?
It's 2. It's 2. So in this case, it was because 1 and 4 is the biggest subsequence. So can we just? I had one question to ask you. So what is the longest increasing subsequence? What is the longest increasing subsequence defined? So is it the increasing subsequence till the element I, or is it seen so far kind of thing?
No, till this element I.
You mean till this element I? You mean like, let's say if I had 1.5. Sorry. Hello.
Yeah, I'm here. We're here. Go ahead.
Yeah. So it's still that element I. So including element I, or is it it can exclude element I also?
It has to include element I, right? If this had been -1, right?
Yeah. It will be
what
1.
What is the longest increasing subsequence? It is
1
because it includes I. It always includes I.
Okay. Okay.
Because none of the elements before this actually includes this, right? So now let's go back to let's keep 4. It at 4 and let's solve it.
Yeah, let's keep it at 4. Okay. So now that element the answer should be 2, because 1 and 4 is the longest subsequence. That's what I wanted to say. Not because 1, 8 is there. Yeah,
that is correct.
5
what about
5?
1,
4, 5. 3. So 3.
3. What about 10?
1, 4, 5, 10 or 1, 8, 10. So that's 4, right?
The longest increasing subsequence will be based on. So the options are it's 110 is a possibility.
Correct.
It could be 1, 8, 10.
10 or 1, 4, 10.
It could be 1, 4, 10, 1, 4, 5, 10. All possibilities are there. So actually the answer is 4.
4, yes. Yeah.
Because you will be all of these elements, 1, 8, 4, 5, all of them are candidates for this. And you look at which is the maximum of that and you figure it out, right?
Okay. Okay.
So let's assume there was a 7 here.
Okay.
For weirdities, right? So what do you think is the value there?
7. So I'll first eliminate the candidates. So it's 1, 4, 7. 1, 4, 5, 7. Sorry. And
1, 4, 5. That's it. No, 1, 4, and 5 are the candidates, possible candidates.
Correct.
Okay,
sorry?
so it's and
No, we are trying to enumerate all the subsequences till 7. The increasing subsequences till 7, correct? So you mean 1 7 4 4 7 like that, or am
so
I?
it is either 1 7 or 1 4 7 or 1 4 5 7. These are only 3 combinations possible.
Or 1 5 7. Yeah.
Not possible, because 5 already have determined that the best value for 5 is 1 4 5 7. 1 4 5, right?
Right. Okay. Okay.
So you don't have to do that. This is the dynamic part of the dynamic programming, where you're actually you've already determined that the best possible sequence that includes 5 is actually a sequence of length 3. So 1 5 7 will not be a condition candidate here at all.
Right. Right. Right.
Hi,
Okay, so
I have a question here. Hi.
Go on.
This is Gaurav. I have a question. Like, why we didn't consider like 1, 8, 10, 19, and 1 11?
No, we are still at 7.
We have not gone there yet. So because the question is that what is the largest subsequence that ends at 7 is a question now. You're trying to get there. We'll fill the whole matrix, right? Good question. We'll come to that in a minute, right? So ending in 7, the longest possible subsequence, the candidates are, you look at all the elements before this which are actually less than 7. The candidates are 1, 4 and 5.
Okay.
So which means you compare all the 3. You see 1 7 is of size 2, okay? 1 4 7 is of size 3 and 1 4 5 7 is of size 4.
Okay.
So 4 is the thing here.
Okay.
For 19, what are the candidates? Everything is a candidate.
Yeah.
Vivek?
Right? Yes, go ahead.
Can you explain again why 157 is not there? Why is it eliminated?
So what we are actually trying to find out is that, so you already have figured out that the subsequence that ends at 5, the best subsequence that ends at 5 is 1 4 5, right? You already know that answer. That's why the value is 3, correct?
Yeah.
So you will never you don't have to consider 1 5 or even just 5. We don't consider those anymore. If the subsequence, the number before 7 includes a 5, then the only possible answer that will give you the best case scenario is 1 4 5.
Okay.
That's what you have determined already in this step. In 31, right? In line 31, the 3 indicates that the best possible combination with ending in 5 is of size 3. You know that.
Okay.
Yeah. Going to the next one will actually help us get a little bit more clearer, right? Yeah. The next one is 19. 19 has everything is a possible candidate.
Correct.
So you can have a 1. Every number before 19 is less than 19.
Yeah. Yeah.
Which means that you will have some kind of a sequence with 119, some kind of a sequence with 819, some kind of a sequence with 419, and so on, right?
Yeah.
We don't know what the sequence is, but that sequence will be the best sequence for 1, which is like just 1 itself. Best sequence for 8, which is 1 and 8. Best sequence for 4, which is 1 and 4. Best sequence for 5, which is 1 4 5, and so on. So the 2 possible answers here is it could be 1 4 5 10 and 19, or it could be 1 4 5 7 and 19. Both answers are 5.
Okay.
Correct. And in this case it's 111, right? If it's 111, it was 11 in the previous case, but I mistyped as 111. So in 111 scenario, the best case is 6.
Yes.
Okay. So is there anyone who does not understand how we got this? Okay. So what is the time complexity for this?
The time complexity is every time you basically have to search for n elements, the k n elements for an element at position k, you search for all the k minus 1 elements before it. So of n square.
Yeah, it's O n square. This is an O n square. What's the space complexity?
O of n, because you need another separate array to fill LIS.
That is correct. So it's a O of n space, O of n square time. N square is not always bad. N square is definitely better than a 2 power n. That is our alternative.
Yeah.
Okay.
Yeah.
So the implementation of this is actually fairly simple. I mean, it's kind of the thing that we talked about before, right? So you just set the first one to 0, and then after that the first one to 1, and beyond that you just have to go through figuring out if there is check all the elements that are greater than the current number, find the max of it. If you don't find the max, then the value is just 1, which is just that number itself.
Okay.
Simple enough?
Yeah.
Vivek, a quick question.
Go on.
So shouldn't that the condition be A of j greater than A of I? On line number 28.
Oh, yeah, right. Li
28.
of j. A of I. I is the element which you are looking at. Right.
Yeah, no, line number 28. The condition should be when A of j.
No, let me rewrite. Let me rewrite that in line number 30. Okay. LIS of I is basically it is max of. So you basically what you need to do is instead of you will iterate through 0 dot dot I minus 1 as j. So Kavita, yes, 11 will be 5, but I have 111, so that's why it's 6. I had mistyped it as 111, so I took it as that's why it's 6. Good catch. So I'm iterating through 0 to I minus 1. That is my j. So the goal here is only those elements where A of I is actually greater than A of j is the one I need to consider, right? J is the one on the left. That has to be the smaller number.
Yes.
Is it not?
Yeah, it is the smallest number.
J is okay.
Right? Array of I is 8. Array of j is everything like 19 is an array. Let's take 19.
You can
array
say
of
for
I
all
is 19.
For all j less than I, we can add that condition if you just make it.
Yeah, I did that, right? Because I'm iterating through 0 to I minus 1. So j is always less than I. You know that.
Correct.
Right? So, okay. That's first step, and then I'm just trying to find max of that, something like that. You're trying to you're trying to eliminate all values of array where A of j is actually greater than A of I. You want to eliminate that. So you only want to keep the scenarios where it's that. There is a kind of a gotcha thing here is you cannot make an assumption that it says it's an increasing subsequence, right? What about equal?
Okay, greater than equal to, is it like non-decreasing? That's what you mean, is it? Is that what you mean?
I don't know if the question is non-decreasing. If I had 1, 8, 4, 4, 10, 19, 11.
Yeah.
Can I have 4 and 4 together? Can I use that or not? I don't know the answer to that.
Okay.
Right? It depends on the interviewer. They may say yes, they may say no.
So tighter condition.
Okay,
yeah.
So in which case your condition here will be such that A of I greater than j could be maybe equal to. That's all.
Yeah.
Okay. All right. So that's about it. Yeah, and I know I didn't leave enough time. I didn't do justice. The dynamic programming questions do take time, but the concept here is that so I don't think it's fair to expect anyone to actually arrive at the solution in an interview. Right? It is not fair. I don't think you would be if I give you this question up front, like with no background whatsoever, I don't think it will be expected of you to come up with a solution. But that being said, if you solve a lot of dynamic programming questions, you will start identifying trends and patterns in terms of how and what kind of memorizations you can keep, and you can start applying this problem. So in this case, if I had given the variation of it being like longest increasing subsequence is one thing I've given, the next question is actually a box stacking question, and box stacking question is a variation of the longest increasing subsequence question. So each of these questions are like, you know, the idea here is that you need to understand these fundamental problems and use that.
Okay.
All right. So any questions?
No.
All right. So it is 5 past, and what I wanted to do was thank everyone for joining the session, and I think it was a great discussion. For folks who participated, awesome. Thank you for your contribution. For folks who have been silently participating and typing in, yes. Amar, which question are you talking about in the face-to-face interviews? Yes, absolutely. Even SDE ones and sometimes even campus college candidates have been asked dynamic programming questions in interviews from Google, Microsoft, Facebook, Amazon. Dynamic programming questions are fairly common, and I believe that's like based on certain teams do have a propensity to ask more of those. So yes, it is definitely a very common interview question, and it's usually not a classic dynamic programming question, but it's almost always like a spin of a classic dynamic question. Dynamic programming question, right? So thank you, everyone. What we'll do is I think some of us have taken notes. If you have taken notes from this and that you can send it to me, please do email me your notes so that I can consolidate them and then put it up on the blog based on the discussions that we've had. And if you have coding examples or things that you've coded that you want to share with me for feedback, I can definitely do that. For people who are local to Seattle, we do have this program in every Saturday in Seattle Tech Interviews. We meet in person. We can do that. I will be setting up the next week's class as well, the same way for online session, and looking forward to seeing you folks there. Please do let your friends know, and if there's anything else I can help with, I'm glad to help. Right? All right. Thank you again, and I think that's all for today.
Thanks.
Thank you. All right. Awesome. Talk to you guys.